Good day, good afternoon, good day to everyone. My name is Nemeka. Um, I'm the data scientist at AI Labs, and today I'm talking about MlOps with Kubeflow, and most specifically deploying TensorFlow models with TensorFlow 7. Yeah, so it's nice to have everyone here, and I'll start now. So actually, there's a link to the code I'll be using today on GitHub. Hopefully it will be shared with you after the session. So it contains everything all the code I'm using for the session today. And yeah, let's go. So where will I start from? I'm going to start by training a TensorFlow model. And okay, sorry, let me talk about the prerequisites. And so today we're going to be deploying like a model on Kubernetes, and I'm going to be using a package called Kind. Kind is short form for Kubernetes in Docker, and I'll be using it in place of Minikube, which I think you guys are using for the stage for in the internship. And it's just because this is quite simpler. It's very simple and easy to install compared to Minikube and the rest. So that's why. And I'm sure people know what kubectl is. It's like Kubernetes command line utility. So it's for like interfacing with your Kubernetes cluster. And so you need to have initially Docker on your PC, then you install Kind, then Kubernetes command line utility this, and you can also, yeah, you also need to have Anaconda, Miniconda or Anaconda, anyone, and have TensorFlow installed in your local PC for a code to run. Get so yeah, so let's get to the code I'm using to do. So today I'm going to train a machine learning deep learning model to classify MNIST handwritten data. I'm sure you guys have heard of the MNIST data sets. How can all right, so the MNIST dataset is a very popular dataset, and it contains handwritten digits from 0 to 9. And so today I'm going to train a model to classify um accurately which number it is. Good. So today I'm going to import most of these libraries, matplotlib, time. I'm going to import NumPy and TensorFlow, Keras API. And this is where I'll get the data from the datasets package. I'm also going to import TensorFlow Keras sequential. This is where we build the model, the dense layer, the conv 2D layer, the max pro layer, the flatten and dropout. These are all important for building your this is all important for building your deep learning model, the actual architecture model. So I'm going to load the data. This is where I load the data from this package, from this dataset package, MNIST data, and I'm going to now print their shape, X train, X test, because you need to train and you need to test. I'm sure you understand that. And also for you to train a model, it needs to be in a particular shape. Like it's supposed to be like a 4D tensor. Like so it's going to be I'm going to just add a 1. What it means that this is initially a 3D. This is actually a 3D shape. But after I add this one, it's not going to be a 4D shape, and it's useful for the model. But this is how TensorFlow operates. And so I'm going to reshape the train and test, and I'm not going to normalize. This is just a typical normalization of the pixel values. You know, the pixel values range from 0 to 255, and so I have to normalize it because this helps the model not to have vanishing and exploding gradients, and it helps the model training. So I normalize, and I now get the input shape and the number of classes, because we're working with MNIST digits classification. You know that there are actually 10 digits from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7 to 9. So the number of classes here will be 10. And so this is where I get that. And now I'm going to define my model. This is where the actual architecture of the model is being built. Um, this is where if you've heard of convolution neural networks, this is where I actually build the CNN. So you use the sequential API of the Keras package and you start adding to it. This is how easy it is to build a model on TensorFlow. This is how easy it is to build a model on TensorFlow. And so like that, I'll be adding layers upon layers. So the conv 2D, this is the actual convolution layer with 64 filters, 3 by 3 filters. I don't know if you guys understand these terms I'm saying, but this is an activation really. So I don't know if I should go deep into deep learning theory, but let me just assume that you understand these things I'm saying. And also we have the max pool. The max pool is for like reducing the spatial dimensions. So the max pool 2 by 2, so it's going to have the spatial dimensions coming from here. Then you have another 32 conv 2D layers with 3 by 3 and ReLU, and we're going to have that, and we're going to flatten. So what this does is that this whole thing from here kind of produces a 3D a 3-dimensional object. Yes, just imagine you have a cube here. Then if you have a cube, then this flattening is just like unboxing everything and making it just a thread, just a line of it. That's what flattening does. And then you're not connecting that output to a 50 neuron fully connected layer. So this is just like a fully connected neural network, fully connected layer. Then you have the dropout. What dropout does is it prevents overfitting. It's a kind of regularization technique in neural networks for you, not for your, because neural networks have a tendency to overfit. So dropout is very important. And what this kind of does is that within every training epoch, it kind of turns off some of these neurons in this layer. It turns them off 50%. That's 0.5, 50%, like 25 will be on at some point, 25 will be off at some point. So it does that randomly. So it doesn't, so it's kind of deep learning theory. And the last but not least is the normal dense layer with 10 neurons that we got from here. And then the activation. What this softmax activation does is that the output of this dense layer is a kind of probability distribution. So there'll be like probabilities from the probabilities from 0 to 1. So each neuron will have a value, the outputs from 0 to 1. The one with the highest probability is the class of it. Yeah. So after that, we now compile. After building your model, you compile with an optimizer. There are different optimizers from gradient descent to RMS prop, and there's Adam. Then the loss function is something like is what is used for training. You get your loss function, and from loss function you do your gradient descent. Then the metric I'm using is accuracy. So I think I'll train the model again so you guys can see what I'm talking about here. The metric is accuracy, and so I'm calling model of it with a batch size of 128 with 10 epochs. And I'm using 10 epochs because it's going to take some time if you go more than that. And you have tendency to also overfit. But this is just a simple demo. Yeah, so I evaluate to get the loss and the accuracy, and I print out the accuracy. And this is where it's very important. Here, this is where I save the model, because I'm going to deploy this model in TensorFlow 7. For you to deploy the model, you have to save the model. And when you save your model, it puts it in a kind of format. It puts it in a kind of folder. I've named the folder MG classifier, and so the model is saved into that folder. So this is the format that is then loaded by the TensorFlow 7 package, or let's say image, that is now saved to the user. Okay, so let me run the code. So I've already prepared like all the code I'm going to use for today. So I'm going to section, we run the code again. Actually, if you can see here, I'm using a conda environment TF. So TensorFlow is already installed into this environment, and I can just I can just run code from it. So if I run the model now, you get some kind of logs from yeah. So this is the train and test size 6,000 by 28 by 28. So they're like 20 the 6,000 images, and this 28 by 28. So 28 by 28 is the number of pixels. You know, in standard image you can see like 1024 by 1024. And so I think I'll stop it because it's going to take some time. But I think you guys understand what I'm going to do from here. So I've already run the code before, and I've already saved the model here in this folder, image classifiers. So everything has been saved. There's this assets, variables, and all. So this is how TensorFlow 7 gets the work done. So now I'm going to talk about the TensorFlow 7 package. So okay. So TensorFlow 7 is like you need there are different formats of using it, but the most popular one is from Docker. So you're going to like load the image, you're going to download the image, the Docker image, and you're going to load it. Okay, let me explain. So this, if you work with Docker files, because I'm sure you guys have worked with Docker files, you know that this from TensorFlow/7 is like it's going to download this image from the latest image from Docker Hub. So if you download that and you now copy, remember that you save the model in this format, image classifier. So it's going to copy it from my local to this particular folder in image. So it's going to now, this is like almost loading it into the image. If you get what I'm into a folder. Like you can have so many models actually. If you look at it, this model is like a folder. Then inside our model, we are putting our particular model into there. And now this one means that TensorFlow 7 permits versioning. You know that after some time, there's things like the model decay and it's not more accurate enough after some time. So you can now train again. Retrain the model, and that can be like a version 2, version 3, version 4, and on and on. And you can like use two versions of models at the same time. There are different ways of saving models actually. So this is what that number one means. It just means that you can version it. And so I will not, for this particular container, I don't know if you guys understand, there's image, there's container, and there's a Docker file that creates the image, that now creates the container. So in the container, it's going to use this particular model image classifier, because you can have a lot of models in it, and you can just choose the one you want to use. So I have actually run this code before, and okay, I've already built it before, but let me just copy it for you. Everything has been in the GitHub before. So yeah, so you can see I've already done it. So it just took like 2 seconds. I've already built it before and everything. So it's already in my system. If I do Docker image, yes. Sorry, Docker image, second. Yeah, you can see that. Yeah, you can see the TensorFlow 7 classifier image that's now available. So that has been done. And now I'm going to like talk about TensorFlow 7. Okay, so it's TensorFlow 7 is like I said, is a way of saving your model. And there now, after you've loaded your model, there's something else. Like you now have to save the model. And in TensorFlow 7, there are like 2 ways to save a model. There is the REST API and there is a gRPC. And each of them have their formats of saving. You know, REST API is a typical one that everybody knows. Like if anybody has done backend or front end or anything like that, I'm sure you've worked with REST APIs before, where you have an endpoint and you make calls to that endpoint and stuff like that. So it's just the typical one that every single server uses, the popular one, and it has different HTTP methods like get, post, delete. And I think the most important thing here is that the payload of the request you make in REST APIs is with JSON in JSON format. JSON format is almost like dictionary. It's actually dictionaries. Okay, no, it's not actually exactly dictionaries. It's almost like dictionaries in Python. So they have the same like the key, I think the key and the value, key value pairs. So it's almost the same. So and also there's a gRPC. This gRPC is a more like complicated form of loading of serving a model, because in gRPC it's it's its payload is actually in protocol buffer, and so you can't just send in your dictionary or whatever into the endpoint. You have to convert that um data into a particular format that is understandable by gRPC. But there's a complexity, but the advantage of that is that it's low latency, and it works extremely large files. Yet when you are doing inference, when you are calling the model. So yeah, that's that. So what I will do now is to just run the Docker image. Yeah, so it's going to get the container. So if I run the Docker image, so if I don't know how to remove this thing from here. Oh, it's kind of blocking. Okay. I don't know. I don't know how to get this stuff from here. It's right. So let me just reduce it here. So this is the code. I know you guys have worked with Docker. So what this is just like it's telling you to run in interactive mode and remove this. This means just to remove the container immediately you are done with it. Immediately you just do the Ctrl C, it's going to remove that container instead of leaving the container in your, I think in your system running, and that port is open. So this /p means ports, and what it does is that you are connecting your port 8501 in your local to port 8501 in the Docker image. And what this means is that actually REST API is on TensorFlow 7. It works with on port 8501. And I think gRPC works in port 8500. But since we're working with REST APIs here, we just need the port 8501. So sorry about that. So if I run this now you see that it's running. It shows that entering event loop. That means it's already running something. So it's open for connections, open for payload to make requests, or for people to send in requests and prediction requests to the endpoint now. So what this means now is that we need to make a prediction, and now I'm going to explain how to make a prediction with on this server, or let's say on this endpoint or this REST API on TensorFlow 7, anyone. So this is the script for making predictions, and what I'm going to do is I'm just going to load the test data. You've trained with the trained data, and now you just want to make a prediction. So as usual, whatever you did for the training, you have to do for the test, which is you have to reshape and you have to normalize. And this is what I've done here. And now this is where it gets interesting. Like there's a specific format for which TensorFlow 7 links are, and I think I have this here. Yeah, so if you look at this, you have the HTTP hosts. The host is my local host here. So because I'm not hosting it on the cloud or anywhere, it's just my local host. And the port is like the port number. The port number is 8501, like as you see, because I'm making a request to a particular port on my PC. So 8501. And like I said that time, your version, so I told you, since we loaded it on version 1, So we're going to make a request to version 1. And now this is just a link to your model. This is a link to your model. Models, like if you remember, we copied the model into the model folder. So you're just linking it to the particular model and the model name that you're working with. So that's why I did your image classifier. Then this predict is just like it's telling TensorFlow saying that you're going to make a prediction. They're taking an action, is a verb. And I think it's well clearly explained on their oh it's clearly explained on their documentation sites. You can always check it out. Just Google TensorFlow 7 and you get the documentation there. And so yeah, so this is the format, this is the link or the way to make a prediction. This is the link, the URL you send your request to. So now making a prediction, you have your instances. Instances is just like your tests, and your tests, like the examples you want to make a prediction on. Yeah, so you convert that to JSON. Like I said, the payload for the REST API is JSON. So you have to convert your instances to JSON. And to do that, you need to put it in a format like the signature name. I think this is not important. What is actually important is this instances. So you have to put it in this format. So you get your instances. This is like a requirement for it in your JSON. And now your instances.list, because this is important because TensorFlow 7 doesn't understand numpy arrays. It doesn't work with numpy arrays. So it's going to get an error if you just put instances there. So you have to convert it to a format that you understand, and that's in list format, array format. Array is like a standard thing in every programming from Java to C++. So list are arrays. So and this is the format that it understands. And these are additional headers you can add to your post request or your prediction requests, the content type, and we're working with JSON. So this is just optional. It's not really important. Yeah. So now after getting the headers and the JSON, you make your request with a post request. Because you are sending data. Like I said, when I talked about the common protocols for REST, you have your gets, your post, your delete, etc., and puts. So for making requests, you need to use the post method. You put in your URL and your data and your additional optional headers, and so you send in your request and you get a response. So the response now needs to be transformed into a dictionary, and so the response, you have to get the text. So the response is in a format, is in a JSON format. So you get your text and you select out the predictions from it. There's a standard way that the response is, and this is just like you manipulating the response to get the actual numbers that you need. You get, so, and you return that. So predictions is, then I'm not calling the prediction function with just, I think four examples, 0 to 4. So you're just going to make it on 4 test cases. You get, so what I'm going to do is I'm just going to print out the predictions it makes. So this is just iterating through the predictions and predicting the true value and the predicted value. Okay, so what this argmax talks is that, like, remember when I told you that the output of the convolutional neural network is the probability density function or probabilities, and so the one with the highest probability is actually the correct prediction or the prediction is making. So the argmax is a method that selects the index of the list that has the highest probability. So argmax just returns the index of the maximum probability. So that's just that. So I think I'm done with that. So I can now run the prediction. System is also running in the background. So I have to now make a prediction. To make the prediction, I just call Python predict.py. Okay. All right. So see, like if I come here now, you see that it's still running, but it's it must have caught like the response or the request. It must have caught the request and made a response. Sorry, made a prediction in the model in the back end, made a prediction and sent out the prediction to the response as a response. And this is what I'm putting. So the model was accurate enough to tell us that, like with all the true values, it predicted accurately each of the actual values we get. So the model was quite accurate enough to tell that this particular digit is 7, 2, 1, 0, if you get what I mean. So um now that I've made the prediction, this is where it gets more interesting. Uh, So what I'm going to do now is that I'm now going to load this into Kubernetes. I'm sure you understand the difference between Docker and Kubernetes. Docker is just like one specific um Docker is just it works with one container at a time. But you know what Kubernetes is? Kubernetes is self-sustaining. It runs different containers at the same time. So that's why I'm moving from just a Docker image to a Kubernetes cluster. And like I said, I'm using kind here, not Minikube. Or there are different Kubernetes I would like say like I don't know, there are different like ways of running Kubernetes clusters in your local. Different methods is Minikube. I think there's one else, and there's Kind. So Kind is just like the easiest to install and doesn't require a lot of hitting of heads to install. You get, that's why I prefer that. It's what everyone can do. So now I'm going to stop this from running. Exited the loop, and now I'm going to show you guys how to run this Docker image TensorFlow 7 in the Kubernetes cluster. So to do that, I just first things first, I have to load the image from my local into the cluster. Actually, there are two ways to do this, but I chose the easy way. The other way is that after creating your Docker image, you can push that Docker image into Docker Hub. You can push your Docker image into Docker Hub and load it from there. Like you just in your Kubernetes configuration, I think your YAML file or your deployment, you could just put in the Docker image instead of. I think you understand where I'm going when I get there. So instead of me going to Docker Hub to download it, since I already have the image on my local, I just load it into Kind, and Kind sees the image and sorry about that. Docker Kind sees the image and just loads it from my local instead of going to Docker Hub and downloading it again from Docker Hub. If I think you guys get what I'm saying. So to load the image, I've already done this before, but just for illustration purposes, I do it again. So you see that image is already present in the cluster. So to get from to move from there, now I'm going to show you guys. I think you've worked with Kubernetes and understand what YAML files look like, but I'm just going to brush through what it looks like. All right, so this is how the deployment of YAML file is. You know, if you want to create a pod or a deployment, you need to have a YAML file. I think you guys know that, and you need to specify how that pod or okay. I think let me assume that you know that a deployment is a group of pods that like work with the same image. I think let me not confuse that. It works with the same image. So a group of pods is a deployment. So let me start by explaining what this means. So like I said, this is going to name a container. This is going to be the name of the container. Now, like I always said, this image here, initially you could have just used the actual. Yes. Now this is if you want to download from Tensor from Docker Hub, or you wanted to use the baseline image, you could just put this here, TensorFlow/7 into here, and it's going to go to Docker Hub and download the image from Docker Hub. If you don't want to do that, you load it into your kind cluster and just use that particular image from kind. So this is what I just did here. This is memory, your resources. You are allocating your resource to each pod. So this is the memory and the CPU, amount CPU uses. So what this means is that memory is just your RAM. So it's going to use 128 megabytes of memory. One container or one pod is going to use 128 megabytes of the memory, and 500 M here means 0.5, and it's this means that it's going to use half of your CPU capacity for that pod. I think, yeah, that's what it does. And so the ports here means your container ports is 8501. So this is just telling when you want to make a request to a particular port, where am I going to make a request to? What port am I connecting to or sending my request to in the pod? So it's port 8501. And now this is where it gets interesting. So this here is selector. So when it wants to select the pods in a deployment, it goes for the names that have tensor for TF7 classifier. So every pod that has TF7 classifier is going to be selected as a part of the deployment, if you get what I mean. I'm hoping that you guys understand what I'm saying. And so this is going to be the name of the deployment, TF7 classifier. I'm sorry for the same names I'm using here. It's just for easy purposes and easy explanation. So that is that for the deployment YAML file and also the service. So you know that a service is like, you have your request. How do you want to get it to your pods where the actual model is running? You get, so you can't communicate to your pods directly on Kubernetes. There are different like steps to take. So you've actually, typically, if you are working on the cloud, you're going to have like the ingress. The ingress is like the entrance to the actual cluster, and the ingress talks to the service. Then now that now talks to the pods, something like that. It's just like a summary. So this is going to be the name of the service, and as you know, the service communicates with a particular pod or deployment, and so the deployment is going to talk to, or pod is going to talk to, is TF7 classifier. So the pods that we created before, and so it's going to communicate to them with port 8501, and it's to communicate to the service. You're going to work with port 80. I don't know. This is almost like networking, but it's just how Kubernetes works. A lot of ports and sending of, I think, for security and other purposes. That's why it goes like this. So when you've created your YAML files, the next thing to do is to just create your pods, if you get what I mean. Create your deployment and create your service. So to do that, you just use these commands. I'm sure you guys have installed, kubectl here. kubectl is a way of communicating with your Kubernetes cluster. So I'm just going to run these commands now. Okay. So now the deployment is created. So if I want to check, just use kubectl get pods test. That is running. Now this here kubectl gets deployment. It's also running. So you see that this is just like a single part of this deployment. But we can see that they're both ready and able to run, able to use. And now I'm going to create a service that communicates with my pods. To do that, you just apply. Remember that they are saved in a kube-config folder. I'm sorry for explaining. In the kube-config folder, there are different YAML files. So that's what I'm doing. I'm applying them and creating them with the apply command. So you can see that it's created, and you can also check that with HDSC, and you can see that it's open. So I just need to explain what this external IP means. It just means that I'm not working on a cloud platform that has access to the internet. I'm just working on my local. So you can't access this cluster from the internet or from anywhere in the world. If you want to do that, you're going to have to build your own Kubernetes cluster, or you're going to use the available ones that are provided by AWS and Azure and Google Cloud services. So that's what that means. So now that we've think we are done with all that. Now I can how can I now save this model? Because since I can't access it online, how can I access the model? And there's a cheat for doing that. The cheat is to port forward. Port forwarding means that since you can't access the service, you can't access it without the ingress. I'm going to connect my local to that particular port in for the service. Remember that let me just explain. Look at it here. Look at the code here for port forwarding. So I'm sorry, this is going to throw an error because the name of the service is TF7 SBC. So what this does is connects port 80 on my local to port 80 of the service, because port 80 is actually where this service is run from our YAML file that we created previously. So that's what I'm going to just support for, because I can't access it because there's no external IP and a lot of the ingress and everything. I can't do that. So I'll just port forward, and if I port forward, you see that it's open to communication. Now I need to make a prediction. Now to make a prediction, remember that we ran this here, but if I run this now, it's going to throw an error. Going to throw an error. HTTP connection pool connection refused. That's because right now we are running on port 8080, not 8501. So to now make a prediction, I have to change it to port 8080. Yeah, this is just for test purposes. So traditionally, you're meant to be able to access it through a URL, and you will not have to do all this. It's all done from the back end and front end. So now if I run the code now, if I say that, yeah, I did. All right, so we can see now that it made the predictions, and you can see that it got like the request and handled the request and sent it to the pod, and the pod made the prediction and sent it back, and we got our predictions out from the Kubernetes cluster, from the pod. And I think that will be all for today. I think for next week, I'm going to talk about KServe and how it's easier to run Kubernetes, like serve models on KServe, instead of creating a lot of deployment and service for each of the, traditionally you won't have just a service. You might have something like Flask or REST APIs like running also, and that also you have to communicate to the pods. So instead of going through all that way and creating service for each and deployment for each of the things they are running, you can just use KServe, and KServe is like a faster way of serving models, and that's what we'll look for next week. So I don't know if there are any questions for me for this session. Let me check the chat. Any questions? Or there are no questions. All right, so that'll be all for me. Have a nice day, everyone. Take